All right, we are now looking at 7b.2. Our MLO is, I can write a ratio for sine, cosine, and tangent by identifying the opposite, adjacent, and hypotenuse of a given angle. Okay, so our new things that we're really looking at is the sine, cosine, and tangent. And again, what we learned today is going to be used throughout the rest of the unit. Okay, so looking at our vocabulary, really we're getting into what the core of trigonometry is. And that's what our unit is. It's right triangle trig. So what is trigonometry? Trigonometry is just the measure, we'll say the measurements of triangles. Okay, and by that we mean angles and sides. Okay. So the measurements of triangles. So what's the measure of the angle? How long is the side? That's what trigonometry is. Then we have these things called trigonometric ratios. And our trigonometric ratios is just the ratio. And a ratio is just comparing using a fraction of two sides of a triangle. And we have three trigonometric ratios that we are going to use. We have sine, cosine, and tangent. Okay? So the sine of theta is comparing our opposite side and our hypotenuse. It's pronounced sine. It's abbreviated S-I-N, but it is not pronounced sin. If you say sin, I'll say I have no idea what you're talking about. The sine of theta. Or whatever your variable. Sometimes we'll have an x, an angle in there. So it's the sine of theta. And that equals opposite over hypotenuse. Okay. So it's comparing the opposite side and the hypotenuse side. Cosine. Cosine of theta, it's abbreviated COS, still pronounced cosine. And cosine of theta. And the cosine of theta compares the adjacent side. Running a little bit out of room. To the hypotenuse side. And then tangent of theta right, abbreviated TAN, but still pronounced tangent, so we would say tangent of theta, is comparing our opposite and our adjacent, and it specifically equals opposite over adjacent. Okay. These you do have to know. Okay, you have to know all three of these. We are using these in every single one of our targets from here on out. So there's lots of practice for you to memorize them. An easy way to remember them is using the word SOHCAHTOA. Okay. It's just an acronym. It tells us exactly what we need to know. Another way of writing it is S over H, C is A over H, and T is O over A. And it's just, again, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? So I'm going to write that on top of every paper. You guys should write it on top of every paper so that we remember it and can always use it. All right, let's look at our first example. Example 1 says find the sine, cosine, and tangent of angle D. So to start these problems, the first thing I need to know is what is the opposite, adjacent, and hypotenuse. Okay, so again, we'll start with my hypotenuse. So my hypotenuse there is 50. Then I need to know what my opposite side is. Well, what angle are we looking at? Oh, I'm looking at angle D, right? That's what it says in the example or in the question. Okay, so across from angle D is the opposite side. And then, right, between the right angle and my angle is my adjacent side. So I'm finding my 3 trig ratios. So I have sine, I'm not going to say theta here, I'm finding the sine of D, the sine of angle D. Okay? And just like up here, sine is O over H. Opposite over hypotenuse. My opposite side is 14. My hypotenuse is 50. Supposed to be green. Okay. And then, just like before, we always have to reduce our fractions. 14 out of 50 is 7 out of 25. Okay. And that's it. Looking at our next example, cosine, or looking at our next piece of it, right? I also have to find the cosine of angle D. Cosine is A over H. My adjacent side is 48. My hypotenuse is 50. I keep not choosing the right color. Again, we can type that in our calculator. When you do, you get 24 out of 25. And then finally, our last trig ratio is tangent. So the tangent of D equals O over A. My opposite side is 48. Sorry, that's wrong. Don't listen to me. My opposite side, O, is 14. My adjacent side, getting ahead of myself, is 48. Again, I always want to reduce my fractions. 14 over 48 is 7 out of 24. And that's it for example 1. So you're really just labeling your side and then writing those fractions. It's a little bit like what we did last unit, right? The side divided by the side, right? We're still comparing or writing ratios of sides. All right, let's look at example 2. And again, I'm going to start, since I had to scroll up, by writing S is over H. My SOHCAHTOA, so that we remember it. Okay? And then I'm going to label my sides. So, all right, across from my right angle is my hypotenuse. Then I need to go across from my given angle. Well, here we're looking at angle E. That's my opposite side. And then between the right angle and the given angle, there's my adjacent side. So let's start with sine. Sine of E equals opposite over hypotenuse. My opposite side is 24. My hypotenuse is 30. And then when you do 24 divided by 30, you get 4 out of 5. So sine of E equals 4/5, or 4 out of 5. Cosine of E equals adjacent over hypotenuse. My adjacent side is 18. My hypotenuse, again, is 30. When we reduce 18 out of 30, we get 3 out of 5. And finally, tangent. All right. Tangent is opposite over adjacent, which equals my opposite side is 24. My adjacent side is 18. 24 over 18, when I reduce that fraction, all right, we get 4 over 3. All right, and that is it for our B2. Go ahead, work on that activity.